Hello students, and welcome to this video in which we will solve 10 more problems of permutations and combinations, that is question number 391 to 400. The video is a bit delayed because I got involved in modifying the format of or rather the tool with which I developed the PDFs. So video got delayed, as well as I have started the question answer website, which I will show you at the end. Okay, both the updates I will show you at the end. Also at the end I will show you how you can download the book from the website and maintain an updated copy. So without further ado, let's get started. Question 391 says that in how many ways can 7 departments be divided among 3 ministers such that every minister gets at least 1 and at most 4 departments to control? So there are 3 possible distributions. We divide in 4 to 1 ways. So number of ways in this case is 7 factorial by 4 factorial multiplied by 2 factorial multiplied by 1 factorial multiplied by 3 factorial. 7 factorial is total number of distributions. 4 comes in denominators as well as 2 and 1. And 3 factorial is because there are 3 numbers or 3 possible distributions which can be arranged in 3 factorial ways. Then we have 2 to 3 ways. So this would be 7 factorial by 2 factorial multiplied by 2 factorial multiplied by 3 factorial into 3 factorial by 2 factorial. 2 has come twice, so 3 factorial was divided by 2 factorial. Then we divide in 3 3 one way. So similarly we have this 420. So total, if you add these 3, you get 1680. Question 392 says that find the total number of ways of dividing 15 different things into groups of 8, 4 and 3 respectively. So this is a very straightforward question based on that formula: 15 factorial over 8 factorial multiplied by 4 factorial times 3 factorial. Question 393 says that find the number of ways of distributing 50 identical things among 8 persons in such a way that 3 of them get 8 things each, 2 of them get 7 things each, and remaining 3 get 4 things each. So again, based on formula 393, right? So 3 of them get 8 things each. So we have 393, right? Okay, 50 identical things among 8 persons in such a way that 3 of them get 8 things, 2 of them get 7 things, and remaining 3 get 4 things. I think this is wrong answer. We will discuss 393 later on. This is incorrect. This should be 50 factorial divided by 8 factorial cube multiplied by 7 factorial square multiplied by 4 factorial cube. That is what it should be. No, that is for the different things. Sorry, it is identical things, right? So identical things will have different formulas. So this is correct. 8 factorial divided by 3 factorial multiplied by 3 factorial multiplied by 2 factorial cube into 2 factorial. So that is 8 factorial by 3 factorial square into 2 factorial. This should be 2 factorial square. So how did we get this? Okay. So these are 3 people. Alright. So 3 people, 8 persons. So 3 people here and 3 people here. 2 of them. That is why 3 factorial has come twice. And 2 of them get 7 things each. Right. So this should come 2 factorial gets 7 things each. I'm confused about this. Okay, I will discuss this in the next video. Let me think. This is identical things, right? Among 8 persons, 8 in the numerator. The remaining 3 get 4 things each. 3, 3 and 2. Okay. 3, 3 and 2, that is the distribution. Okay, so this is wrong. 3, 3 and 2, this is correct. Okay, 3, 3 is 3 factorial and 2 factorial will be here because that is one group. This is wrong. Okay, these two should not be there. 2 factorial should not be there, and 2 factorial should not be there. Right. So let me think a bit more. Okay, why do we have this? So two of them get 7 things each, and then we have two groups of 3 people. That is why probably it is multiplied by 2 factorial and then divided by 2 factorial twice. I'm not sure about this, but this is certainly correct. Question 394 says that if 3 different things can be equally distributed among 3 persons in k ways, then find the number of ways to divide 3 things in 3 equal groups. So 3 things can be distributed among 3 persons in 3 factorial by n factorial cube, that is k ways. These can be put in groups, 3 groups in 3 factorial by n factorial cube into 3 factorial, that is k by 3 factorial ways, so based on direct formula. Question 395 says that find the number of ways in which n different prizes can be distributed amongst m, which is less than n persons, if each is entitled to receive at most n-1 prizes. The number of ways of giving all prizes to one person is MC1. Thus, total number of ways of giving prizes is m to the power n. So the answer is m to the power n minus m. So we have answer as m to the power n minus 1 multiplied by m minus 1. Very straightforward question. Question 396 says that n different toys have to be distributed among n children. Find the total number of ways in which these toys can be distributed so that exactly one child gets no toy. So clearly one child out of n minus 1 will get 2 toys. One child can be left out in n ways. The extra toy can be chosen in n ways. Remaining n minus 1 toys can be distributed among n minus 1 children in n minus 1 factorial ways. However, if the child getting 2 toys gets toy A as the extra toy and toy B as the ordinary toy, this is the same as if the child gets toy B as the extra toy and toy A as the ordinary toy. So we have counted 2x as many combinations as we need. So the answer is n multiplied by n times n minus 1 times n minus 1 factorial by 2. That is n factorial times MC2. That is also an easy question. These questions are very easy. Question 397 says that find the number of non-negative integral solutions of x1 plus x2 through x5 is equal to 8. So we have to find non-negative integral. So xi's can have value from 0 to 8. So one of these can have a value of 8 while remaining can have value of 0. Thus it is an arrangement of 12 objects, 8 of which are of one type and 4 of which are of another type. So total number of such arrangements is 12 factorial by x factorial multiplied by 4 factorial, that is 495. Question 398 says that find the total number of positive integral solutions of x1 through x5 is equal to 8. So in this case it is positive. So for like previous problem, xi's can occupy value from 1 to 4. If one of these have the value of 4, remaining 4 will have the value of 1. Thus, it is an arrangement of 7 objects, 4 of which are of one type and 3 of another type. So the arrangement is 7 factorial by 4 factorial multiplied by 3 factorial. So see, these are positive. Okay, so you take one from each and subtract on that side. Okay, so this will become so we let say y1 is equal to x1 minus 1. So 8 and 5 will become 13, right? y1 plus y2 plus y3, y4, y5. Where y1, y2, y3, y4 will be non-negative solution. So it will become 13. And then you solve like previous case. So we had 12 factorial here. Okay. And so we added 4. So in this case it will be 13 and 4, 17. This should be 17 factorial. not 7 factorial. Okay, let's see. It can occupy value from 1 to 4. Okay, fine. If one of these have value of 4, remaining 4 will have value of 1. 4 of which are of one type and 3 of another type. So 4, one of these will have the value of 4, remaining 4 will have value of 1. Okay. Yep, looks good to me. 399 says that find the number of integral solutions of x1 plus x2 plus x3 plus x4 is equal to 14, where x1 greater than equal to minus 2, x2 greater than equal to 1, x3 greater than equal to 2, and x4 greater than equal to 0. So here we let x1 is equal to minus 2 plus x1 prime, x2 is equal to 1 plus x2 prime, x3 is equal to 2 plus x3 prime. So equation can be written as x1 prime through x4, 3 are primes, that is 13, because x4 is greater than equal to 0. So we are converting everything to be greater than 0. So we have 13, and now the solution is simple. There is 16 factorial by 13 factorial into 3 factorial. That is 560. So how did we get this? So this is our things. This is n. So 4, 13 plus 4 minus 1, c, n minus 1. Okay, so 16C13, that is what it is. All right. This formula we could have used to solve these two as well. Okay. So let me try to do that. So we have to find positive solutions here. So we let y1 is equal to x1 plus 1. Okay. Or rather x1 minus 1. So x1 is equal to y1 plus 1. So similarly you do for x2, x3, x4, x5. So y1 plus y2 plus y3 plus y4 plus y5 will be 3. So r is 3 and this count is 5. So n is 5. So n plus r minus 1 would be 7. C n minus 1, that is 4. That is how you got 7c 4. That is 7 factorial by 4 factorial multiplied by 3 factorial. That is how we got the answer. And in this case, we have non-negative integral solution. So r is 8 and this is 5. So 8 plus 5 minus 1, that is 12. So we have got 12 here. And c n minus 1, that is 4 here. So this is 12c4. So both the answers are correct. All right. Now we come to the last problem of the set. How many integral solutions are there to x plus y plus z plus t is equal to 29, where x greater than equal to 1, y greater than equal to 2, z greater than equal to 3, and t greater than equal to 0. So following like previous problem, we let u is equal to x minus 1, v is equal to y minus 2, and w is equal to z minus 3, where u with w are greater than equal to 0. So we get u plus v plus w plus t is equal to 23. So total number of solutions now would be 23 plus 4 minus 1, C4 minus 1, that is 26C3 or 2600. With this, we come to the end of 40th set of problems. Now I'll show you the websites, two websites. So you can go to ashtavakra.org and download algebra from second link, trigonometry from third, and coordinate geometry from fourth. These PDFs, so you need to add this date to the downloaded PDF, so that when you come back later, probably in 15 days, if the date changes, you can download again. Now, why this coordinate geometry book is going to be delayed is you read this. I'm converting coordinate geometry book to doc book. This means we will have HTML and PDF both. Okay, algebra and trigonometry will be converted at last. After coordinate geometry, I will write calculus and then probability, and then algebra and trigonometry will be converted to doc book. Okay, that is one thing. The second thing is you can come to kunjika.ashtavakra.org. This is the question answer website I have created. So you can ask questions here. Right now you cannot, but the tags I will create, then you can ask the questions. So right now there is only one user, that is me. Okay, you can see my face there. It's very old photo. All right. So register, it only requires an email, nothing else. If you have an email, you can register. There is no password setup, nothing. Just pick a username and log in. You will receive a code at your email, copy and paste that, and you will be logged in. That's it. Okay, no password problem. All right, every time you want to log in, you will have to give a code which you will receive at your email. So if you have any questions, you can come and ask here. This supports math also. I will write a help file to show how math can be written, and tags I will create. So tags will be algebra, trigonometry, connectivity, calculus, and probabilities for now, for math subjects. And for programming, I will create other tags. Okay. So feel free to make an account here and ask questions. I'll try my best to answer those. Okay. So with this, I will end the video here. I hope that you are enjoying this series of videos. If you have not watched previous videos in the playlist, then you should go ahead and watch the previous videos. And we will meet again tomorrow with 10 more problems on permutation and combinations. So once again, thanks a lot for watching the video, and I'll see you in the next one tomorrow. Till then, keep learning and have a nice day.